Hello geometry folks, and welcome to coordinate geometry and parallelograms. So today you're going to need your notes, a pencil, and a calculator, and you also need to have those handy formulas ready that we talked about yesterday, as we will be using them today in our quest to be able to determine if the figures that we have are in fact parallelograms. So we need to have those formulas out and ready. All right, so first and foremost, how can we show a quadrilateral is a parallelogram? By what we used yesterday. So we kind of need to know what a parallelogram is and the characteristics of a parallelogram. Well, one thing that I know about a parallelogram is that both pairs of opposite sides are parallel. Now, thinking about that property, what formula did we use yesterday that would allow us to show that both pairs of opposite sides are parallel? So when I think of the word parallel, the first thing I think about is using the slope formula. Okay, so we need to be able to use the slope formula in order for us to help us determine if that quadrilateral is in fact a parallelogram. Another characteristic is that we can show that both pairs of opposite sides are congruent. So when I think of congruent, both sides are exactly the same length. And when I think of length, I think of distance formula. So we will use the distance formula to show that a quadrilateral is a parallelogram by showing that both sides are equal in distance. And then a third property that we should know about parallelograms is that you can show that a quadrilateral is a parallelogram if the diagonals bisect each other. So when I think of bisect, I mean cut in half. And when I'm thinking diagonals, I'm thinking about going from opposite corner to opposite corner. And so that would be using the midpoint formula. So the midpoint formula is going to help us determine if a quadrilateral is in fact a parallelogram. Okay, so we need these three formulas. There are tools to help us with today's lesson on coordinate geometry and determining if a quadrilateral is a parallelogram. Okay, so let's get started and do the very first problem. Make sure that you have all this stuff written down. All right, so let's go ahead and do this first problem. It says, given these coordinates, show that both pairs of opposite sides are parallel. Show. Okay, show doesn't mean you're going to draw the figure and then just point it out. Show means algebra or the work behind it to prove that this quadrilateral in fact has both pairs of opposite sides being parallel. Now, if they don't turn out to be parallel, then we can't say it's a parallelogram. We would just say it's a quadrilateral. Okay? So thinking about coordinate planes, let's just kind of see where all these points would kind of fall. So if I were going to graph these points, I would have 0, 1 here. This is A. B is 4, 4. You know, I'm just guesstimating. 12, 4 would be here. That would be C. And 8, 1 would be about right here. And that would be D. So if I want to show that this quadrilateral is in fact a parallelogram, I need CD to be parallel to AB. And I need BC to be parallel to AD. Okay, so the question that I have is in fact AB parallel to DC? Okay, that's the first thing I need to do. Plus, I need to show both pairs. So I also need to show that BC is in fact parallel to AD. So I'm going to do this by using the formulas that we know would be associated with parallel. So what I associate with parallel is slope. So I need to have the slope formula ready. All right, So let's go ahead and do the slope formula here and figure out if AB is in fact parallel to DC. So I need to find the slope of both of these sides. So let's start with AB. Okay, so I need to know the slope of AB. Now remember, A is 0, 1, and B is 4, 4. Okay, and the slope formula is the difference of the y's, so y2 minus y1 over x2 minus x1, and that would give me 3 over 4. Okay, so I have a slope of 3 over 4. Now I need to find the slope of DC. Okay, so the slope of DC, I'm going to use points D and C, so 8, 1, 12, 4. Okay, slope again is the difference of the y's over the difference of the x's. Okay, I get 4 minus 1 is 3, and 12 minus 8 is 4. And 3/4 in fact is equal to 3/4. So yes, AB is parallel to DC. Now, in order for you to be a parallelogram, you can't just have one pair, you have to have two pairs. So now we have to figure out BC and AD. So now I'm going to figure out BC, so I'm going to just write these points down here so I don't forget what they are. So BC, I need to find the slope again, so it's 4 minus 4 over 12 minus 4. 4 minus 4 is 0, 12 minus 4 is 8. That would be 0, because 0 divided by anything is 0. And now we need to do AD as well. And A is 0, 1, and D is 8, 1. So the difference of the y is 1 minus 1 over 8 minus 0. 1 minus 1 is 0. 8 minus 0 is 8. 0 divided by 8 is again 0. And again, these two slopes are the same. So these two sides are in fact parallel. And because both sides are parallel, it is a parallelogram. Okay? We can conclude that this quadrilateral is in fact a parallelogram. Okay, let's do another one. So now what I want to do is I want to, given my points, I want to show that both pairs of opposite sides are congruent. So when I think of the word congruent, I'm thinking length, which means distance. So I want to use the distance formula. Okay, so let's kind of set this up so we know where A, B, C, and D are here. So A would be -2, 3. So here's A, -5, 7. There's B. 3, 6 would be C. And 6, 2 would be D. Oops, I got D in the wrong place. Sorry, 6, 2 is over here. There's D. Okay, so I just kind of want to get a general shape here so I can kind of see what I'm looking at and what sides I'm looking for. So I want to show, if I want to prove that this is a parallelogram, I need both pairs of opposite sides congruent. So I need AB congruent to CD, and I need BC congruent to AD. So showing that algebraically using the distance formula, I want to ask myself, is AB in fact congruent to DC, and is BC in fact congruent to AD? Okay, so I'm going to need to use some distance formulas here. So let's start out with AB and go from there. Okay, so AB, and I want to use the distance formula, so I have to get the distance formula out. AB is my ordered pairs are -2, 3, and -5, 7. And I'm going to do the difference of the y's, because it doesn't really matter which one I do first, plus the difference of the x's. Okay. And that's squared. Okay, so this is 7 minus 3, which is 4 squared. Don't forget the square root. plus -5 minus a -2, that makes a +2, so that would be -3. Okay, and 4 squared is 16, and -3 squared is 9, and 16 plus 9 is 25, and the square root of 25 is 5. So the distance of AB is 5. Now let's find the distance of DC. Now if the distance of DC is not 5, then we can stop right there and say these aren't parallel. I mean, it's not a parallelogram. But if they are, then we got to do the next set. Okay, so DC, here we go, 6, 2, and 3, 6. So the difference of the y squared, so 6 minus 2, plus the difference of the x's squared, 3 minus 6 squared. Okay, and then 6 minus 2 is 4, and 4 squared, plus 3 minus 6 is a -3. And that would still be 16 and 9, which is the square root of 25, which turns out to be 5. So yes, these are in fact the same distance, and so they are congruent. Now we have to prove that BC and AD are congruent. So now we're going to do BC. Okay, B is -5, 7, C is 3, 6. I just write those coordinates down so I don't accidentally take the wrong one by looking up at the top. That's why I keep taking them and bringing them down. So it's the difference of the x's, so 6 minus, or x's or y's, we're going to do y's first. 6 minus 7 squared plus the x's would be 3 minus a -5 squared. All right, and let's see what happens here. 6 minus 7 is a -1, so I got -1 squared plus 3 minus a -5, which is 8. Squared, which would be 1 plus 64, and the square root of that would be 65. The square root of 65, I'm not going to do that in simplest term. I'm going to use simplest terms if I can. I'm not going to use decimals this case. There's nothing that goes into 65 that I know of, so I'm just going to leave it as the square root of 65. Now, hopefully, the next one is also the square root of 65, so we can say that this is, in fact, a parallelogram. So A's ordered pair is -2, 3. D is 6, 2. We're going to use the distance formula again. So the square root of the x's is 6 minus a -2 squared plus the y's, the difference of the y's. Like I said, it doesn't matter which one you put first or second. You can put the difference of the x's first or the difference of the y's first. That really doesn't matter. Okay, 6 minus a -2, that's an add. That means add, so we're going to have 8 squared. And 2 minus 3 is -1 squared. And that would be 64 plus 1. And that is still the square root of 65. So yes, these are congruent. And this is, in fact, a parallelogram. Oops, I am totally messing that one up here. Okay, so here we go. Let's redo that here. It is a parallelogram. Okay, so we've used the distance formula, we've used the slope formula. Guess what? The last one is probably, yep, midpoint, because those are the 3 that we learned. All right, so again, let's kind of draw our figure out and see where our figure would be. I'm going to do a different color here. So -3, 0 would be there. That's our A. And then we have -3, 4. That's our B. We have 3, -1. That's our C. And we have 3, -5, which is our D. So this is kind of what our shape looks like. And we want to see if it's a parallelogram by showing that the diagonals bisect. So we're going to use midpoint here. So when we're using midpoint, we want to use the diagonal BD and the diagonal AC, and we want to find out if they match up with their midpoint. So if AC's midpoint is the same as DB's, then we will have bisecting diagonals, and they will be a parallelogram. All right, so the first thing we want to do is take the diagonal. It doesn't matter which diagonal. Let's take BD and find its midpoint. Okay, so midpoint, okay, if we've got B, we've got ordered pair. Just going to do the ordered pairs here again so I don't accidentally take the wrong one. And I'm going to use the midpoint formula, which says take the x's and add them together and divide by 2. Take the y's and add them together and divide by 2. And 3 plus 2, or 3 plus negative 3 plus 3 is 0. And 0 divided by 2 is 0. 4 plus a negative 5 is negative 1 divided by 2. And so the midpoint would be 0, negative a half. All right, that would be our midpoint. Sorry about that. So we've got the midpoint of the diagonal BD. Now let's do diagonal AC. Okay, so I want to find the midpoint of AC. So again, I need A and C's ordered pairs. And it's add the x's up, negative 3 plus 3 divided by 2, and add up the y's and divide by 2. And negative 3 plus 3 is still 0, and 0 divided by 2 is still 0. 0 plus a negative 1 is negative 1, divided by 2 is 2, and so the midpoint is 0, negative a half. And because these midpoints are exactly the same, then we can say that this is a parallelogram. Okay, so we used 3 formulas to help us determine if our quadrilateral that we were given is in fact a parallelogram. And we are going to use those formulas to practice that tomorrow. So that's all, folks, and we'll see you later.